we are going to do a walkthrough on Date Planner, which is a Swift playground app. In this project, we are building an app. It lets people create events, add tasks, and most importantly, remember those events even after the app closes. Let's jump in and see how it all works step by step. First, the app stores all of its event data in a variable called event data. This variable uses something called @state object, which tells SwiftUI, hey, this object matters, please keep track of it. Because event data is observable, SwiftUI watches it closely and automatically updates the screen whenever the data changes. Next, we pass event data into the event list view. Event list is the very first screen you see when the app opens, so giving it access to the data means it can show all of our events right away. To stay organized, the app uses a collection of event objects. Each event represents a real-life activity, like a birthday party or a camping trip. By making event confirmed to identifiable, we help SwiftUI recognize each event as unique, just like giving each one a name tag. Every event stores all the information we need: an icon, a color, a title, a date, and a list of tasks, and this ID as well. Those tasks are things you need to do, like buy snacks or pack a tent. Or we can see camping trip, game night, health checkup, and a lot of other things as well. You will also see some computed properties in event. These are smart values that help the app group events by date and show how many tasks are left, making the app feel organized and helpful. We can see there is the date for next 7 days, there's this, and there's the next 30 days and future, and we have this past over here, and this if and else statement check for date. If it's less than what the date is right now, then it will return the past value, and that's how this event model works. Next, an event task represents one small to-do item for an event. Just like events, tasks are also identifiable, so SwiftUI can update them smoothly in a list. Each task stores text, whether it's completed and whether it's brand new. When someone finishes a task and checks it off, the app sets is completed to true, so it can track what's left to do. Now let's look at event data. This is the brain of the app. It stores and manages all events shown on screen. Because it confirms to observable object, SwiftUI automatically tells every view when something changes. Here we can see a color, a title, a tasks, and a date. And all of these event data has an array that starts with some sample events, like game night, or a doctor's appointment, or health checkup, or camping trip. And by marking this array with @published, SwiftUI knows to instantly refresh the UI when events are added or removed. Next is the event list. The event list view displays events using a grouped list, which keeps everything clean and easier to read. The app passes event data into event list using an observed object. This lets the view react immediately whenever the data changes. No refresh button needed. The app uses navigation split view for navigation. On larger screens like an iPad, this shows multiple columns side by side instead of stacking screens. When someone selects an event, the second column shows the event editor view. If no event is selected yet, the app displays a friendly placeholder message instead. To build the list, the app loops through different time periods, like the next 7 days or future events. If there are events in a time period, the app creates a section and fills it with the correct events using sorted events period function. Each event gets its own event row, showing important details at a glance. To delete an event, the app adds swipe actions. Swiping left reveals a delete button, which removes that event from the data just like many real apps do. Right now, the app forgets everything when it closes. That's not great. Let's fix that by adding data persistence, which means saving information even after the app restarts. There are a few ways to do this. User defaults works well for small settings like theme choices. For bigger data, we can use local files or databases like core data. Since our event list is small, we'll use File Manager to save everything locally on the device. But here's the challenge, our app uses an array of event objects. To save them, we need to turn them into a format like JSON and then turn them back later. Turning data into JSON is called encoding, and turning it back is called decoding. Swift makes this easy using the Codable protocol, which Event already supports. The getEventsFileURL method finds the app's private documents directory. Only this app can read or write files here, which keeps your data safe. Instead of always using sample events, the app should load saved data if it exists. The app calls getEventsFileURL inside a do-catch block, since file access can fail. Next, it reads the file into memory as raw data, which is still JSON at this point. Using JSON decoder, the app converts the data into an array of event objects. Now the app can use the saved events like normal. If loading fails, the app safely fallbacks to the built-in sample events and uses the catch and the print functions to display what went wrong. To save the data, the app uses JSON encoder to turn events into JSON. Once encoded, the app writes the data to the file location provided by getEventsFileURL. If something goes wrong, the app prints an error message so developers can debug it. Awesome! These same save and load methods can be reused in almost any app you build. When event list appears on screen, the app calls load using the task modifier. This loads saved data before the view is shown. At first, nothing changes because we haven't saved anything yet. Whenever someone edits an event, the app detects the change and calls save automatically using that on change off function. Woohoo! Now the app remembers events even after closing and reopening. Try adding a new event, relaunch the app, and watch your data come back. So I'm going to do that. New event. Let's choose an emoji, choose a different color, and write something. Thank you for watching our video, and as always, we hope to see you again.